Imagine you're sending a simple message from New York to London. Just a few words. You press send. A second later, it arrives, almost instantly. Most people never ask how. Some believe it travels through satellites. Others imagine it moves through the clouds. After all, the internet feels invisible, so it must travel through the sky, right? But here's the surprising truth. Your message probably never went into space. Instead, it traveled thousands of kilometers beneath the ocean, across the darkest places on Earth, through cables no wider than a garden hose, quietly connecting entire continents. Every email, every video call, every online payment, every cloud file, every AI request makes the same journey, not through the sky, but across the ocean floor, hidden far below the surface. Today, we're following that journey, because once you discover where the internet actually travels, you'll realize the world's most important network has been hiding in the last place most people would ever look.
Look at a world map. You'll see continents separated by oceans, thousands of kilometers of water. Now ask yourself, if the internet connects the entire world, how does it cross that distance? Most people imagine satellites. It sounds like the obvious answer. After all, satellites already connect the world. But architects know satellites carry only a very small part of global internet traffic. The overwhelming majority travels somewhere else, beneath the ocean, across thousands of fiber optic cable, stretching from one continent to another. Imagine building a highway, not across land, but across the deepest oceans on Earth. That's exactly what humanity has done. These cables are carefully placed along the ocean floor, passing through seas, oceans, entire continents, quietly connecting countries that may never even share a border. Most people believe the ocean separates the world. Architects know the ocean is where the modern world comes together. Which raises an even bigger question. If these cables carry almost the entire internet, what exactly is moving inside them?
Imagine holding a submarine cable. From the outside, it looks strong, heavy, protected, built to survive the ocean. But hidden at its center is something surprisingly fragile. Glass. Not thick glass, not reinforced glass, just strands, thinner than a human hair. Most people find that hard to believe. How could something so fragile carry the world's internet? The answer is even more surprising. Electricity isn't carrying your message. Light is. Every photo, every email, every video, every AI request becomes tiny pulses of light, flashing millions of times every second, racing through glass, across oceans, across continents, until they reach their destination. Imagine standing on one coastline, turning on a flashlight, and someone thousands of kilometers away seeing the exact pattern of every flash. That's the basic idea. Not with ordinary light, but with precisely controlled pulses of light, moving at extraordinary speed. Most people believe the internet moves through electricity. Architects know Across the world's oceans, it travels as light, silently, continuously, without stopping. Every second, countless streams of information cross the ocean floor. Not ships, not airplanes, not satellites, just light, hidden inside glass. But if these cables carry so much of the world's information, another question appears. Who builds them? And perhaps more importantly, who owns them?
Imagine building a road, not across a city, not across a country, but across an entire ocean. The project would take years, thousands of people, specialized chips, advanced engineering, and billions of dollars. Now imagine doing it again and again until every continent is connected. That's exactly how submarine cables are built. Most people assume the internet belongs to no one. Architects know its infrastructure is built by many organizations, telecommunications companies, infrastructure operators, technology companies, working together to connect the world. Because no single company can build the entire internet. Each cable is a project. Each landing station is a gateway. Each connection becomes another path linking continents. Over time, those individual projects have grown into one global network. Some companies build new cables to connect their own data centers. Others share infrastructure to improve global connectivity, not because they're building different internets, but because they're strengthening the same foundation. Most people see a video call. Architects see thousands of kilometers of engineering. Ships, engineers, fiber optic cables, landing stations, international cooperation, quietly working together long before anyone says hello. But laying a cable across an ocean is only the beginning, because once it's there, it must survive one of the harshest environments on Earth.
Imagine a cable stretching across an entire ocean for thousands of kilometers. Now imagine leaving it there for decades. No roof, no walls, no security guards, only the ocean. Most people would assume it couldn't last. Architects know these cables were designed for exactly that. From the outside, a submarine cable looks simple. Inside, it carries tiny strands of glass. Outside, multiple protective layers shield it from the environment. Because surviving the ocean isn't optional, it's the design. Deep beneath the surface, the ocean is surprisingly calm. The greatest risks often exist closer to shore, where ships drop anchors, fishing equipment touches the seabed, and human activity becomes unavoidable. That's why some sections are carefully buried beneath the seafloor, adding another layer of protection. Most people believe once a cable is installed, the job is finished. Architects know the work has only begun. Every cable is continuously monitored. Every signal is carefully measured. If something unexpected happens, engineers know almost immediately. Specialized ships can be deployed. Remotely operated vehicles descend into the ocean, finding the damaged section, lifting it to the surface, repairing it, then carefully returning it to the seabed. Sometimes the internet travels thousands of kilometers without interruption, not because nothing ever fails, but because someone is always ready when it does.
But even the strongest cable cannot connect the entire world by itself, because every cable must eventually reach land. And where it does, another hidden piece of the internet begins.
Every journey must eventually come to shore. After traveling thousands of kilometers beneath the ocean, the cable doesn't stop there. It reaches a cable landing station, a place most people have never heard of, yet one of the most important on the entire internet. This is where the underwater world meets the land, where continents begin talking to one another. From here, the journey continues across fiber networks, through internet exchanges, toward data centers, until the information finally reaches the computer waiting to answer. Most people believe the internet is one giant network. Architects know it's countless networks working together. Submarine cables, landing stations, fiber optic networks, internet exchanges, data centers, cloud infrastructure. Each one solves a different problem. Each one depends on the others. Remove just one layer, and the entire experience begins to change. Because the internet was never built as one machine. It became one system, built piece by piece, connection by connection, generation after generation, quietly growing until it became the infrastructure supporting modern civilization.
And perhaps the most remarkable part is this. Every time you send a simple message, you unknowingly trust one of the greatest engineering systems humanity has ever built. Most people see the ocean as something that separates the world. Architects see something different. They see the highways of the internet, hidden beneath the waves, quietly carrying conversations, knowledge, business, entertainment, artificial intelligence, and the digital lives of billions of people. Because every connection between continents begins with a cable most people will never see. Once you understand that, you stop asking, "How did my message reach the other side of the world?" You begin asking, "What invisible infrastructure made that possible?" Because every connected civilization needs more than technology. It needs architecture. This is NextNet, inside the modern internet.